Okay, my friend, today we keep going on with our beautiful piscine. As you can see, we have a lot of exercises which are very similar. For example, string is alpha, string is numeric, lowercase, uppercase, printable, string uppercase, and lowercase. Basically, we have the same issue, the same problem, given in a different flavor. But once we learn how to resolve one exercise, we can resolve all of them. So we're gonna tackle the first, and by domino effect, we're gonna understand all the other ones. The very first one is str is alpha. We have to create a function that returns 1 if the string given as a parameter contains only alphabetical characters, and 0 if it contains any other character. All right, pretty easy. This is gonna be the prototype of the function, so it's gonna return me an integer and takes as an input char star, namely a string. It should return 1 if the string is empty. All right, let's jump into the code. Here we have all the program in all its glory. I created this super fancy main to make my tests, but the function itself is super short and easy to understand. Now, very briefly, we're gonna check my main so you can appreciate what I did, okay? So basically, I created an array of 2000 chars. So I have in my stack a data structure of 2000 bytes, because a char is 1 byte. The name of the structure is str, of course, for string. Then I declare a j and a char c that I'm gonna use in my while loop that you will see now. Then I declare a while 1. Basically, this is the way you declare an infinite loop. When you say while 1, well, this expression is gonna always resolve in true. The 1 is always true, so you get an infinite loop. Inside my infinite loop, which is not infinite, otherwise the program won't never finish, so I have a trick inside this loop, you will see. I assign the value 0 to j, you will understand later what it is for, and then with these 3 lines, I'm gonna create a random string. Now we're gonna understand these cumbersome expressions. I have another while, so I have a nested while, and then I have this very strange expression. We're gonna solve this exactly like the computer does, okay? Here I have an assignment, so we're gonna resolve, first of all, this random function. This is a very simple function that you surely know is gonna return me a positive, random, or better, pseudo-random number. To use this function, you have to include the standard library, okay? So, just by chance, let's pretend that this function is gonna resolve in 100, okay? The next expression that we have is 100 modulo 95, which is gonna very easily resolve in the number 5, right? Very easy. Okay, then we have this 5 plus 33, we get 38, okay? Very easy. Then we can finally perform this assignment. We're gonna assign to the char c, the one I declare at line 63, the value 38. And you know, the funny part is that when you assign a value to a variable, that expression is going to resolve in the value assigned itself. So if we have c assigned 38, we get here the value 38 itself. This is a variable that I can use. And this is exactly what I do in this Boolean expression. I'm going to say 38 is different to 127. Yeah, of course it is. So what do? You're going to assign to str, namely my array, in position j, which is 0, right, at the beginning, the char c, which is the char 38. What is this 38? Well, as you perfectly know by now, a char is just a 1 byte integer. So we have this char in this case, this random char, which is the ampersand. So in the first iteration, I'm gonna assign to my array in position j the ampersand char, okay? Then what do? I'm gonna increase j by 1 position because I have this postfix increment, and I keep going on with my loop, with my expression. So every time I have a new char, a new random char, which is in the range 94 plus 33, you see? Here, as you easily understand, you can get a value which is from 0 to 94. This you should know by now, so I'm not gonna repeat to you. Otherwise, we are gonna spend too much time here. So from 0 to 94 plus 33. It means that I can have a char that is ranging from 33 to 126. You see here, I have the first 32 chars which are not visible, okay? Or better, not printable. These are just for formatting reason. I will explain in this video later more in depth what I'm talking about. Then we have from 33 to 126. We have all the chars that are printable. We have a series of symbols. We have the alphabetical, uppercase chars and lowercase chars. And then we have at the last position, this 127, the lead character, which is a strange char that you will very soon will learn what it is, okay? So basically with my super strange expression, I'm gonna say, hey, fill my array with random chars ranging from 33 to 126, namely all the printable chars. My sentinel value is the 127. I can reach this value because 94 plus 33 is gonna be exactly 127. So just by chance, I'm gonna hit this number, this sentinel value, that allows me to get out this loop. Once I get out this loop, I'm gonna append a 0 to the bottom of my array that I will use as a sentinel value for my string ending, okay? So 3 lines to create a gibberish random string. If you decipher step by step, it's super easy, right? Then what do? I just have a fancy printf. Basically, what do? I print my random string. You see, in this first position I have a s, and then I give as a first parameter to printf the string itself. Then I do a ternary operation. I call my string is alpha function. You know that this function is going to return 0 if the function contains non-alphabetical chars, and 1 if it is 0 or it contains only alphabetical chars. So I say this function will return me 1. Well, in that case, you just print the first string. Namely, the string contains only alpha chars or is empty. If this function is false, you see the exclamation mark is kind of prompting your mind to think in a question, this function, right? Is this false? Is this true? You can think about that with ternary. It's super easy. The first spot is for the true value, and the second spot is for the false value. You have this colon to divide the true result from the false result. I think ternary is kind of cool. Then at the bottom, I just have a fun condition just to make more enjoyable these programs, which are super boring in my opinion. That's why I have this fancy main. Here I say, if the string contains indeed only chars and the string length is major than 10, what do? Well, you break the cycle. So we can finally get out this infinite loop. We have this condition, namely, what do? I'm going to create randomly strings that contain gibberish value from 33 to 126. And I'm going to search for a string that contains only chars, and it is at least 10 chars long, okay? This is the program. So we're going to run, we're going to appreciate the output, and then we're going to understand the function itself. Okay, as usual, I compile the code, and then I just run. As you can see, here we have my random string that is at least 10 chars long, and I have the output. This string contains only alpha chars or is empty. In this case, I have only alpha chars. But you see here, I have an empty string, and as well I have the output. The string contains only alpha chars or is empty. That's because I have to return 1 if the string is empty. Okay, now we're gonna watch the function itself. I wrote 2 functions, string is alpha, one normal and one pro, quote unquote pro. Namely, the notation is different. One is more cryptic, more evolved, if you want. And the other one is the one pedantic that will allow you to understand very well what is going on. So let's start from the easy one. I declare in the first line an iterator, and I will assign to it the value 0. Then I call the while loop. And the condition for this while loop is that while str at position I, which initially is 0, is different from 0, namely the sentinel terminating null character. So what is this expression? Very simply, while I have a string, while I still have a string, I will increase I, reaching the last position. I think this expression is super easy for you by now. Then what do? Inside my loop I say, if str in position I is major equal, then lowercase a and str in position I is minor equal, then lowercase z. Namely, all this expression you can read, if the char pointed by str I is in the range lowercase a, lowercase z, or the char in position I is major equal, then uppercase a and uppercase z, well, what do? Well, you just increase I. Are you getting the point here? Basically, the condition is that, is the char that I'm pointing with I an alphabetical char, uppercase or lowercase, I don't mind. You see, I'm just telling with this expression, is the char in this range, namely from 65 to 90, or in this range here from 97 to 122. In this case, I've used the char themselves, but I recall to you that they're just one integer numbers at the level of computers. So if I write 97 or if I write char A, they are the same. Computers understand only numbers and not even decimal numbers. These are as well abstraction. 97 is the decimal representation of a binary number. On the RAM, we have only binaries. You will see later. The program contains binary numbers, okay? So if the char pointed by I is an alphabetical chart, what should you do? Well, you just increase I. You want to check the other position, then the other position, the other position. So you're gonna exhaust all the string searching non-alphabetical chars, okay? On the contrary, what do? Well, you return 0. If this condition is not true, what does it mean? Well, it means that you stumbled upon an alpha, namely a char which is not in this range and in this range. You stumble upon something else that can be in this range or in this range, I don't know. You got the point, right? You stumble upon a char which is not an alphabetical one. So it's just simply return 0, you see? Because, oh, I found an unchar. Basically, my work is finished. This is a string that contains non-alphabetical chars. All right, in this case, the function will end. On the contrary, if I never stumble upon non-alphabetical char, I will reach a point in which I stumble upon my sentinel char, \0, okay? So I will exhaust my string, the condition is not true, and I jump to this level. At this level, I'm gonna return 1. In this case, what do I know? Well, I know that or I have exhausted all my string and I haven't found any non-alphabetical chars, or the string is empty, you see? At the beginning, I get into this loop only if the string has some value, namely at the first position, I don't have the null terminating char. So if the string is empty, what is gonna happen here? Well, I'm gonna skip this while loop and I jump immediately here, you see? So I return 1 immediately. The logic is very easy to understand, right? I don't have to explain you more than that. At this level, I'm sure that the string is only made of alphabetical chars or it is empty. This is the function. Super easy, right? Now I want to show you the pro solution. Mamma mia. So you see, I have just a few lines here. Let's decipher what I wrote. As usual, I have the while. This time I dereference str and I use the value pointed by str immediately as a Boolean value. If I have the null terminating char, this will result in false. And if I have every other char, this will be true, okay? Another thing is that I use the pointer notation, which is the real one. The compiler is gonna always do that. You see, at this level, I use the square bracket notation, but this is just the so-called syntactic sugar, because it's easy to see, right, what is happening here. I use the square bracket, and this really recalls an array at the cell position I. Okay, it's super easy to see. So it's syntactic sugar made for ease of reading, and this is perfect. You should use this square bracket notation, but bear in mind that what happens all the time, you have this dereference of str, which at this level is a pointer. See, in my main, I have an array, and then I'm gonna pass to the function str, namely, I'm gonna pass to my function the array that at this level has decayed to a pointer to the first element. This is another very important concept I explained already in a previous video, so I prompt you to watch if you are confused now, okay? Then what do I do inside my while loop this time? I'm gonna say if, let's just forget about this exclamation mark by now, and then I do this very strange expression. I say at str, so I dereference my str pointer. It's major equal, then this binary number, and str is minor equal than this binary number. I think you already understood what is going on, but I want to show you a trick, something that you may find interesting. With this slide, you see the binary representation of all the ASCII chars. You see, I have the upper chars that start at the number 65, right? And the lower case chars that start at the number 97. Look carefully at the binary representation of these numbers. You see 65 has this peculiar binary representation, namely you have 0, 1, 0, and then you have a 1 at the bottom. It turns out that this is very cozy for representing alphabetical elements. It is like all the letters of the alphabet have a prefix and the number, namely the position of the letter itself. You see, for the uppercase, I have 0, 1, 0, and then I have 1 for the first letter of the alphabet. Then you keep going on, you have 0, 1, 0, 2, namely for B, and so on. You got the point. To represent all the alphabetical chars, I need 5 bits, because 2 to the 5 is going to be 32. Namely, I can fit inside 5 bits all the 26 chars. And I have still a little buffer of 6 combinations that I can use for some other symbols. The same idea holds for the lowercase chars. This time we have a prefix of 0, 1, 1. 0, 1, 1, and then we have the position of the alphabetical char, right? 1 for A, 2 for B, and so forth. Very easy. With the ASCII code, we know that the first bit is not used, right? The biggest ASCII char is 127, which is the delete char. So we can basically forget about the first bit. It is always 0 for chars. So look now, I have the uppercase chars that I have the upper bit, you know, the most significant bit that is turned on, and the bit on its side which is turned off, right? This is like saying, hey, this is an uppercase char because I have only the uppercase bit turned on. While on the contrary, if I have also the lower bit turned on, well, we have a lowercase char. So for the uppercase char, I have 1, 0, and then the char itself. And for the lowercase, I have 1, 1. Okay, this is a cool trick, I guess, for you. Maybe you may find useful. I don't know. So long story short, we have 65 and 97 representing uppercase A and lowercase a, just because, look at that, it's super easy to spot the alphabetical char even by the binary configuration. Here I see the first letter of the alphabet, the second and the third, and so on, until I reach 26. The same idea, of course, holds also for integer chars. You see, here I have the prefix and the number. This time I only need 4 bits to represent the number because I have 10 digits, and 4 bits give me 16 possible patterns, so I have enough space for all 10 digits and more. So as usual, I have my prefix. I can forget about the first bit because it's always turned off. And then I have 0, 1, 1. And then what do I have? As before, I have the number itself. You see how easy it is to spot the number. 1, 2, and 3. Cool, right? So to sum it up, the binary configuration of the ASCII chars is not totally random. There is an idea behind what is happening. We can consider that we have some bits that are flags, and then we have the position of the letter for the alphabetical chars, or we have the number itself in its binary configuration for the chars. Okay, you may find this useful, and we're gonna apply immediately in our code this principle. This trick allows you to really understand what is going on at the run level, and to write code which is really what is going on in real world. For example, look at this code this time. I said, while at str is major equal than 0b, this is the prefix to write directly in binary. C allows you to write directly in binary, it's super cool. And then you say, you know that alphabetical chars have a prefix of 3 bits, right? Because I need 5 bits to represent all the 26 alphabetical chars. So I have 0, 1, 1. This is the prefix of the lowercase chars, right? Do you remember? Because I have this bit turned on. And then I have A. You see the letter A here. I have 1, namely the first letter of the alphabet. Here what do I have? I have another binary number, still the prefix 011 for the lowercase, and then I have 11010. What is this number? Well, you have 16 plus 8 is gonna be 24, right? Plus 2, 26. How many letters in the alphabet? Well, 26. This is the binary representation of the letter Z in lowercase. Then what do I do here? Here I have the prefix 010. I have only the uppercase bit turned on, and then I have a 1 for the uppercase A. Okay? Here the same trick. Prefix 010, and then the number 26 for the uppercase Z. You see? I have written in binary the representation of the chars, and I would argue it's very easy if you understand the logic behind the ASCII code. I mean, you will impress your friend if you write code like that, but you know deep down that it is super easy. The first bit I can forget is always turned off. These 2 bits are the flags. If only the first one is on, it means that it's uppercase. If also the second one is turned on, it means that it is lowercase. And then the 5 bits are just for the position in the alphabet of the letter. Okay, you understand that this expression here is basically the same as this one. It's exactly the same. Of course, this one is much more readable, and it is the way you should write. Everyone should be able to read your code. That's the main point of having the square bracket notation as syntactic sugar, and to have chars written in its human readable form. But at the end of the day, these are numbers. These are 1-byte numbers written in binary. What is happening at the level of computer, you have a dereferentiation of a pointer to the first element of the array. The computer will find in 1 byte a configuration representing something. Then I have this exclamation point, which is very interesting because it's going to invert the logic of the expression. So let's read in human words the string. It's going to say, hey, the char pointed by str is in the range of uppercase chars or in the range of lowercase chars, namely, is it a lower or uppercase alphabetical char? Let's pretend this is false, namely, this is not an alphabetical char. I stumble upon, for example, the char 42, which is the star. So at the end, you will end up with this exclamation point and the result false, namely 0. Here we get an invert, so this false will become true. So at the end, what do I get? If true, so I get inside this block, I return 0. You see, I just inverted the logic. If I stumble upon a value which is not an alphabetical one, with the expression I wrote, I'm able immediately to return 0. Inverting the logic with this bang, with this exclamation point, call it as you want. On the contrary, you just keep going on with the string, searching for the next char. Okay, so this is just a fancier way to write the same function. They are exactly the same. And we're gonna run the chew function again. So I have alpha normal. Okay, I just save this one and I'm gonna run. You see there, this works exactly. It's gonna search for the only alpha chars. And now I'm gonna test the alpha pro, which has this super strange way of writing. I'm gonna run again the function. As you can see, it's exactly the same. It's exactly the same function. You should always strive to write code which is like that, which is sugar for people. I have to read the code and I have the impression that I understood everything at the first glance. You see, I have the curly braces for every block here. The else block has curly braces, even though I have only one line. I have the square bracket notation to reference the array. I have this redundancy saying different from 0. I don't use directly the char pointed by str in position I. And basically, everything is more sugary. That's what I want with code. Here, good luck, right? They are the same programs, but look how cryptic it is. I use binary here. I use the referentiation of my array that has decayed into a pointer to the first element. Then I use this exclamation mark that is going to invert the logic. Here, I use directly the value pointed by str as a Boolean value. I don't use the curly braces to create a block here because I have only one line, so I can skip the curly braces in this case. But you see, everything is more cryptic, but they are the same. They are the same program. Okay, that's it for this first exercise. Now we have str is numeric, which is the same, just we have to control if the string contains only numeric numbers. Basically, that's the same program as before. Exactly the same. I have the same main. And then I have the chew function. Let's very briefly watch again the code. I have while at str is different from 0. Here I use some redundancy to say different from 0, but you understood that this piece of code is not necessary. Then I say if at str is major equal to 48 and str is less equal than 57, just keep searching. Otherwise, you stumble upon a non-integer char, so you just have to return 0. Here I have the return 1, which is or the string is empty or the string contains only alpha chars. The same program as before. What is the difference? Well, the difference is that we change the ranges, 48 to 57. And this, of course, is the range of numbers, right? From 0 to 9, 48, 57. As I explained to you before, we start 0 from 48 because it's very handy in its binary representation. I can see immediately the number 1 from its binary representation. Very handy. So basically the logic is the same as before. I don't have to explain you nothing more. Let's just run the code again just to search for a string. You see, here we have 746. The string contains only integer chars. Perfect. str is lowercase. Do I really need to explain to you how it works? Very briefly, let's watch the code. This time we have a different range, which is from 97 to 122. You see, 97, 122. This is the range of lowercase chars. For the uppercase, what do we do? Again, same idea. This time we change the range in char major equal 65, char minus equal 90, which indeed is the range of uppercase chars. Beautiful. Okay, this is the last exercise we're going to do in this little marathon, which is it's printable. Create a function that returns 1 if the string given as a parameter contains only printable characters. Now I want to show you something interesting. Online, I stumbled upon this very beautiful page that explains all you need to know about the ASCII char encoding, history, and basically everything. The bit width. Have you ever wondered why we have 8 bits but we use only 7? Here you have the answer. And here we have the control codes and the printable chars. Control codes give you all the ASCII chars that are not printable. They perform some format stuff. For example, you perfectly know the backspace, which is the number 8 in my ASCII code. The backspace is for eliminating a char, right? You have all the explanation of this ASCII char. So here we have the backspace prime function deleting the char before the cursor, okay? This is the char number 8 in the ASCII code. Then we have the tab that you perfectly know. The tab is going to be 4 spaces, right? In normal cases. And then we have the line feed. It is the one you use to go on the next line, right? Probably this is the one you know better. Here we have a lot of these chars which are not printable. We have from 0, which is the null character we use to terminate strings, to the number 31, which is unit separator. I frankly don't know what is this. Basically, I don't know a lot of them. I know tab, new line, and so forth, but there is plenty of chars. Then we have even this 127, which is the last char representable by 7 bits. You see, here I have all the possible bits in my ASCII code which are turned on. This is the delete character. This is strange to understand what it's for, because you see, I suggest you to come here and to read a little bit, but you have always to keep in mind that this ASCII code was developed for teletype machines. You wonder what this TTY means when you launch a terminal. Well, this stands for teletype. Once upon a time, the real teletype was this, now I'm gonna show you if I find, was this machine. You see, this is a teletype. It's a very cumbersome machine, mechanical machine. Now, this dude here is a magician. The channel is Curious Mark. I also suggest you to follow this dude. He's making crazy stuff with computers. Let's watch a little extract from this video.
There is no equal sign, there is no... Okay, single line editor. No.
You see, basically this is a teletyper. A very mechanical machine that is performing stuff. So, here we are. The commands in the ASCII code were original for this kind of machines. So this delete was essentially a command for the teletype mechanical machine. Then just come here and read this paragraph so you will understand by yourself what I'm talking about. Nowadays, basically, this char is useless for digital teletype terminals. I will leave you a link in the description of this beautiful page, which has been done by Dmitro Koshovia. My friend, you're the best. Thank you very much for this amazing resource. Coming back to us, the idea is always the same. I just search for chars which are in a specific range. In this case, I say major equal 32 and different from 127, namely the last char, which is the delete chart. This expression I say, hey, is this char printable? Is major equal than 32? 32, for reference, is the space char, and different from 127, namely this very useless nowadays delete char. Because for deleting char, we use the backspace, right? The number 8 in modern computers. So I simply say keep going on until you find non-printable chars, and then return 1. So this time, maybe the interesting part is that my main is a little different. I have all the char possible. I get a char which is in the range 0 to 128, which is my sentinel value, because it is not a char. My last char is 127. Let's run for the last time this code. You will hear a lot of time the bell char. I will explain you later what I'm talking about. You know, you hear the sound, pam, pam, pam. What is that? Well, this is the bell char. It is the 7, which is like this fancy sound in the Mac. You see, here I have a lot of mess. Look at this, a lot of strings. There is all gibberish. And I stumble, at the end, I managed to stumble upon this string, which is only with printable chars. Perfect. All right, my friend, I think that from exercise 2 to 6, you understood the point. You have to understand very well the ASCII code, And basically that's it. I highly suggest you to check this resource if you want to learn everything you need to know. Here you have all the things to become really, really good in this topic. And the ASCII code is really important because it underlies the transmission of information of nowadays computers. So really important topic. All right, that's it for this video. Thank you very much for watching. Enjoy, my friend. Bye.